So let's talk about Elon Musk saying that SpaceX is shifting the focus on colonizing Mars because colonizing Mars will be on the back burner. But let's just focus on trying to colonize the moon. So let's talk about it. So if has been researching about the future of space travel as of recent, we know that Artemis 2 is getting ready for launch to send humans back to the moon. With the successful launch of Artemis 1 back in 22, this was a orbit around the Earth to escape Earth's gravity and then head straight into the deep, vast distance between Earth and the Moon on a 3 day, 96-hour trip to the Moon. And then this is going to orbit around the Moon a few times and then come all the way back. This time, Artemis 2 takes it a step above by actually sending humans that same direction to orbit the moon and back. So yeah, 96 hours to get to the moon, which is 3.5 days. But still, it's a 10-day mission because you still have to orbit around Earth a few times to escape the Earth's gravity, so you can slingshot it, and then you have to orbit around the moon and use the moon as a slingshot, and kind of makes that little trajectory kidney bean shape. Um, and there's been some talk about sending humans to the moon's surface, but just in a different location. So instead of humans being set where the Apollo program was landed, they're actually sending their sights on the south pole of the moon to understand the physical geography of and the geology of the south pole, understanding how we can use water ice as fuel, because deep under these craters there's abundance of water ice that just the sunlight can penetrate deep in those craters. So we'll learn how to survive and we'll learn how to live on different environments of the south pole of the moon, just depending on the sun's angle on the south pole because the moon is tidally locked to the Earth. So yeah, that's what's going to be happening with the Artemis program in the near future. Um, Currently, the Artemis 2 is kind of on the back burner due to a fuel leak on one of the O-rings on one of the engines. So they kind of had it scrubbed for a little bit. So it was supposed to be launched back in February 6th, but now they actually delayed it until March. So next month, basically. So yeah, hopefully the dress rehearsals keep going good and they fix whatever needs to be fixed for a very successful mission next month. So yeah, but there's also been some focus on colonizing Mars, but also there's been some other recent studies about potentially sending our sights on Venus. And I know what you're saying. Isn't Venus' surface crushing? Isn't Venus' surface so hot? Well, not like that, really. Colonizing Venus, but it's in its upper atmosphere where it's possible, where it's much cooler temperatures, that it's habitable for survival. So it's not too hot, not too cold. So yeah, that's kind of what we're talking about with Venus lately. So Elon Musk is saying that we're going to be taking the back burner of future Martian colonization because the original plan was we're going to send humans to Mars by 2050, right? The first human colonization, these big mega dome like cities here and there with solar panels, domes, and generators, nuclear reactors, this and that. And there's been some talk with future Artemis missions by actually building nuclear reactors on the moon. I think it's going to be on the very last Artemis programs between Artemis 6 and Artemis 7 when we officially send humans. We gather humans that are going to be sent to the moon. So yeah, that's what's going to be happening. So we are closer to 2050 now as of recording this. We're in 2026. 2025 is in the direct middle between the year 2000 and the year 2050. We're 1 year ahead. So we're 1 year closer to 2050 now. So yeah. So 2050 is in 24 years. So what happens between now and the time of recording this, between now and 2020, sorry, 2050, sorry, 24 years. Think about all the technology that's going to be happening for interplanetary missions, especially what technology is right now. Rovers are starting to use AI technology. NASA's already installed it, and it's becoming more into the news of using the AI to self-drive these rovers, across the Martian surface as well. And then we build rovers on the moon that can use AI technology, because you have to think about how AI is right now. AI is becoming very realistic, creating realistic humans based on AI. You can't even tell which is fake versus what's real because of just how AI everything is becoming. And then AI is so good at replicating voices here and there, but not just as good, but it's good, just okay, basically. That's just what AI is becoming. So basically, it's not perfect. It will never be perfect. I'll say it once and I'll say it again. It's just AI. I mean, think about AI from 5 years ago that didn't really exist. AI from a year and a half ago to 2 years ago, it was kind of just that infant stage of, there's things that AI really screws up on based on, making videos with AI. And then now look at what AI has become just in that short period of time. AI is used everywhere. And, you can decide between what's real versus what's fake. And a lot of people use AI for lots of different things. Now AI is also being used on future Martian travel or lunar travel as well. It's just explosive right now. But shifting that focus between the Mars colonization by putting it on the back burner, this is where I'm kind of gonna defend it. So basically, if you understand um, what's going on with distance wise, give me one second. I'm gonna bring some props. So here I brought is some props, some styrofoam planets and the moon, of course. Let's start with a very simple exercise to understand what's happening. So, if we were to shrink down Earth to about the size of a styrofoam ball, and we scaled down the moon to roughly about, this is pretty much the size of the moon compared to the Earth if it was shrunk down. So, this is the exact scale, pretty much. So, I've said this in a previous video beforehand, and I will do this again. How far do you think the moon is if we scale down the Earth? Well, some people might say they're about this far apart. That's what most textbooks and, just art shows you. Actually, in reality, if you shrunk the Earth down to about that size and the moon about this size, the moon will actually be 30 feet away. It will just be in the next room. But let's scale it down further. Here I have just Earth in just a different form. So we shrink the Earth down to about this size, and then Mars being half the size of Earth, basically, and just in that size comparison. How far do you think Mars is if we shrink Earth down to a size of a school-room globe? It will be a mile away. Mars will be a mile away from Earth if we shrunk it down. Do you know how long it takes to actually get to the moon? It will take 3 days. Going to Mars takes 6 to 9 months. And what's so hard about going to Mars is when we look at it, Mars and Earth are not, you know, they're in far different places around the sun. They're on opposite sides of the sun. If you want to travel between Earth and Mars, it's going to be a very difficult time because for Earth and Mars to kind of line up between Earth and the sun and Earth to Mars, you want to wait for Earth and Mars to line up. The opposition takes 26 months, 2.5 years for these two bodies to line up. And that makes the trip time much harder because again, you have to follow this L2 kidney bean shape um, to escape the Earth's gravity and set their sights on at a very boring, dark 6 to 9 month journey straight to Mars. And you have to orbit Mars as well to slow it down too and successfully land. So that's why it takes so long to get communication between you and Mars. Communication between you and Mars only is about 20 minutes there and back. So if you're having an emergency on Mars, chances are that it's not really the emergency is not going to be there because again, it takes 6 to 9 months to get between Earth and Mars, and communication is only 20 minutes away, right? So sending people on Mars, it's just a one-way trip to just learn to survive on your own basically, and just what do you do? I mean, really, yeah. I mean, communication's very, just not much communication between you and Mars. So that makes it so hard if you have a big delaying injury or something or a sickness going on. You want help, and if you have um, rations between food and supplies to build stuff, well, you still have to wait 6 to 9 months, or maybe longer than that, because, like I said, the communications are different. They may vary. So yeah, so basically, just sending a one way to Mars, it's just survival chances are very low. But still, we are setting our sights on going to Mars, and like I said, but put aside all of that, my ego says, yeah, we're gonna colonize Mars, and it's gonna be the first interplanetary home, basically. And I say it's our dream to just figure out what life is like on Mars. How we can build cities, big mega cities on Mars or underground cities. Understand the Martian environment too. But that's just my ego. But that's the reality. What I said earlier was just the hard part. Now with the moon, yes, the moon's communication between moon and Earth only 1.25 seconds. So there is a 1.2 second delay. So it takes 96 hours to get to the moon, basically. And yeah, so that's 3.5 days. So you can send stuff in just that amount of time. That you can send, reactors and building materials and communications and rations and, figure out how much stuff you have to pack and all that stuff. And that's why with the future of Artemis missions, right? Sending humans back to the moon is going to be a game changer for interplanetary missions. And in conclusion, our dream is to colonize the stars, basically. But sometimes it's just very difficult because, again, you know, you have to deal with the opposition. You still have to deal with communication. You still have to deal with, what if things go wrong, basically. And that's kind of what I want to talk about, and kind of what to defend on what Elon Musk was saying. Basically, putting that back burner on colonization of Mars, and then just shifting our focus on the moon because the moon is our nearest neighbor, very close by. It's 30 feet away from our model Earth, basically. I said that's 3 days, right there. 1.25 second delay of communication. So that's much easier than just shipping the first millions of people and building on Mars. Because like I said, it takes a very long time because you still have to wait for Mars to just become lined up to each other. And that's it. But thank you guys so much for watching. I'll see you guys in the next video. Bye.